So it's that XE.
Good morning, ladies and gentlemen. How are we doing today? Wonderful. Get to work. Let's go. Hey, it's work. My bad. No, it's not your bad. You're just ignoring me. Really? Yeah. So when I told you to do something and you didn't do it, what do you call that?
You're not listening.
Which is ignoring me. Then you're listening if you heard me.
Well, you're not ignoring.
MG12.
Two different things, Brian. I think not.
What? I don't know.
You just do.
Oh,
oh my god, no, I was looking at Megan.
Anytime.
Where are you going to see?
So it's not always 52.
Benton.
I was like, so it's just
Oh yeah, that's perfect. Because that 10 plus 2 is.
Next week have a Monday?
Oh, I don't know. Is this right?
Yeah. 3P6.
You just count the elements.
So then what is
What do you mean you just?
Oh.
I got 10 times 1, 2, 3, 4, 5.
This takes the place.
Yeah, you're always right.
Why didn't you have XE? Well, XE was this one here.
Oh, so you gotta put the element.
So what's the one before this? Who gets before magnesium? Any.
Oh, okay. That makes sense.
Now, by writing any there, you're taking
Still
the
close.
2S2, 2P6. First of all, that should be everybody done.
Okay. I didn't know that.
So if you write a noble gas core, it takes the place of writing everything up to it. And now you just need to describe everything after it until you get to the element in the next row.
Okay, that makes sense.
3P6.
Yeah, that's so much easier.
That's so much easier than I thought it was.
So 24.
Where's 2
Oh, do I need the 3D10?
Oh, right.
I think so. Oh, wait. I'm missing one.
Where's 2
I'm missing one.
Waiting for the
Do you have the... It's okay.
Okay, because I introduced them right at the end yesterday. Noble gas cores are a shortcut way of writing an electron configuration. What noble gas core do we use for magnesium? We use neon. So magnesium is in the third period of your periodic table. It is element number 12. So you have to go to the noble gas in the row above it, which is neon. So you put the noble gas in brackets, Ne. And then you put 10 by it. Why 10? Because that's how many electrons are in neon. And now you go and you write in the row that the element is in all of the configuration that is necessary. So if you only need to do the S's part, that's all you do. If you need to do the S's and the P's, that's what you do. If it's in areas, or if it's in the fourth or fifth, you might have to have S's, D's, and P's. Okay? So again, for bromine, what period is bromine in? What period is the element bromine in, please? 4. So what noble gas core would you use? AR, and you would have 18 by it. Okay? For osmium, number 76, what period is it in? So then what noble gas core would we use? Xenon, Xe 54. So from there, ladies and gentlemen, you still need to describe everything in the row to get to that element. So for magnesium, you're describing this part here. For argon, you're going all the way, for bromine, you're going all the way across over to here. For osmium, you're going all the way from here to here. And when you're done, you still should be able to add up all of your powers and get the correct number of electrons. Go to work, ladies and gentlemen. If you have questions, raise your hand. I'll be happy to come over and help.
Okay, I think I have to put 4 as well. Would you put 4? But then, did you put the 3D10? So that I put 3D6.
So where are you at?
I was doing the bromine one.
Okay, so you covered the here.
Yes.
So what are these?
That's the S's.
Which ones?
The S2.
No. What number S?
Wait, no, you can just look at 16.
1S, 2S, 3S, 4S, 5S, 6S.
Oh, 4S.
Okay, so you're going all the way over to here, right? So you have to list these. Then you make it past these.
Yes.
So what are these?
These.
Which these?
The 3D10s.
Good, so you put that in.
Okay.
Then you go over into here. What are these?
The P's.
Which P's?
The 1, 2, 3.
No. The number in front.
Oh, 4.
There you go.
Oh, okay, that makes sense.
Please remember, you always have a number in front of a letter, S, P, D, or F. There's always a number in front. Okay? Always a number in front.
So start with what is first in that period. Remember, this belongs in here.
Yeah, that's the part
So
that's.
what's first?
30, 31.
Okay, start with 7S2.
Oh, that's a
Every
5.
energy level begins something S2. Something S2. Okay. So now, what do you get to? To down to here, right? Okay, so you gotta get to there. What's that? Thank you. In terms of electron configuration, what is that? What's that? Which is 61 as you get past it.
Sorry. I got it. Okay, so it makes it. Okay, wait, so we're looking for S, so 76. Oh, no.
You will never use this.
We have to
as a
go-
noble
we have
gas
to go
core
through
unless
these,
you want
right?
to write it out that
Okay, so it makes it.
Everything from here to here is already described.
Yep.
So now you just gotta do this one.
It's in the 6. It's in the 6.
These are
6 S2.
This one here.
Is that what you have?
Hey, you have it right.
Third period.
I hope you realize that I can't agree with
You're describing everything from the first to second.
Or
Is that like writing?
14. Yeah.
Yeah. So you don't have to do one S.
5D. Yeah. Okay, let's do the math. So 20, 23. Wait, I think I did it wrong. Unless I did it wrong. No. It gives what? No, there's a less one. Yes, look.
76. We have extra one.
Exactly.
So we don't do the 5
But like,
Right.
Like easier.
I've taken the place of the right way. I'm checked.
Just like saying
Okay, so now try. So it's 20.
describing the electrons.
Wait. 20, 22. That gives you 6. Oh yeah, wait,
Okay,
76.
so that's what I'm trying to show you. Because this would be written this
So
way.
you're already here.
I can
We finished the second book, so now we're going through the first.
I just wanna understand why we don't put the 5D.
The last
Present here.
he's always.
Because
So
Yeah.
one that is P6, 3P6, or 3P6.
Well, I don't know if it's like it wasn't like standing.
Or is it because we're starting
Like you rotated it.
here?
Chill.
We ignore it.
We were learning about this.
I just wanna understand
The
that.
social part of it, like,
That
and we're
Or
talking
you got
we just have an hour.
So you're on
I thought it was
here.
a
So you gotta so then you can describe all the
Oh. The way we determine it is, okay,
No,
this is the element I was trying to write.
So we would have to go right on the left, right on the.
Yeah,
That's what the noble gas is all in P6. So here, we said that P6, 2P6, and 5P6. We said that 3P6 and 5P6. Now, the way you do it without having to write all this first is Osmond, this period right here. So we're going to use
Oh my god, my dad is
Good
stuck.
because that'll take up the place.
It goes 7
I
S2.
have
So instead of 4, it would be
So the one that's
Okay, so 7 S2, 6D. So then now it's 6D.
That's how we do it.
Because-
So we're saying, okay, by writing this, we're coming from all of this up here.
Which
Now
is
I
good.
just need to
But
account.
we do need it because.
Yeah.
But why didn't it work here?
Nope, this is in 7, so the one above it is.
So 6D
and the 2S.
1. Yeah.
Above it.
Oh, 5F. And then 5F3.
When we're doing this, when we did Brody, we went on to our.
Hey, and that gives us 92.
When we did magnesium, so you go above it because that's where you have less electrons. If you use the one at the end of the row,
4S.
118, that's already beyond the 92
More
that you're
energy.
trying to
Okay, so you have to be.
To get to
Yes.
five.
Okay, shoot.
I remember he was here
Yep.
with the Packers winning games.
61 because it, you know,
Correct. Okay, now here's the difference. The difference is the 61 is in here. This is the 5D1, right?
Okay, so first we're gonna start with.
Okay. Well, because we were getting to this one, right? So this 5D1 is accounted for when you put 5D6 here. Because it was 1, 2, 3, 4, 5, 6. Okay. Here, when you're stopping here, I'm not getting to all of these. So I need to include this 61 because it fills before these. Okay. But these completely fill these Fs before the 5Ds finish filling. Okay.
Occasionally.
So if you're gonna land somewhere in here in the Fs, you have to include either the 61 or the 5D1, because otherwise you'll be off by one. But if we go past these into this area here, that D1 is already accounted for because this was D2, D3, D4, D5. So that D is already accounted for. Okay? So if we're in the S, we need to single that one out, otherwise we're gonna be one short. But if we get past it, when we get back into the Ds, we've already counted that one in our Ds to get to the fifth one out.
Yeah.
Okay? Does that make
Yeah,
sense?
that makes sense. Thank you.
Good. Oh, yeah. Questions?
These are.
Your band. Yeah.
We're going all the way to here.
Yeah, maybe.
Okay. So to get here, we end up going
I kind of can. I'm supposed to live next year.
Yeah, I just said it.
Actually. And then I have my jazz on. 11 something.
Oh my god, I'm so happy because I have my at 1 and actually my birthday on
So yours are close together, mine are
I know, and I feel like just that watch like
I'm kind of hoping that Mr. Pickle.
What about?
He was there last year and he was harassing me and Danny the entire time.
Like 4 and 7.
Literally.
This one will be
You're
right
in.
here. This is 5D. This is 5D. So to get this 5D6,
Oh,
we have a group.
okay, that meant like that meant like
Okay. So
that's not gonna
He's also
I got you're supposed to celebrate and you're supposed to celebrate it.
Wait, so it's going to like one of these.
Yeah.
This one is right?
we're gonna make our own text.
They're just making us work. You still have to add
So if you don't.
Oh yeah, we can
You're a 16-year-old girl.
You know.
Yeah.
So it was Tuesday we did rehearsal and
Historically.
and Mr. Secret plays some like Daddy called him Buffalo and then Mr. Secret actually heard his
Steely White, I'm like, people
Well,
call
at the
it
same time,
white
it sounded
dog.
like Mr. East.
Yeah, that's it. Are they wrong?
Mr. East.
These are like
Meditation.
Oh, they're like,
Okay.
But it's his sounded
You're
different
missing.
though. It sounded like
Yeah.
lobby.
So because you're stopping in here in the
I think before Rhapsody, they should put on.
we need to listen.
People could assume that you have bad food.
Really?
People could assume that I own this salt.
But I think I'm gonna go there a little earlier. Well, no, you get the
Like
essence.
that. Here, because we got all the way to the states. Here, already added.
So, you're gonna put
We're stopping. We're stopping here, we got writings. Well,
shoes.
Correct.
Yeah, you should. I wanna practice like me and Danny's too.
All right, ladies and gentlemen, here we go. All right, Josie, finish magnesium.
Like the brackets, 3S2. I didn't know what you wanted.
3s2. Okay, so after we have gotten through neon, in the third energy level, we stop at the second element. That is the 3 S's, because it's the second one, 3s2. There are your 12 electrons. All right, finish off bromine here, Faith. So we got argon 18. Go ahead from there. Not 2. They're 1 behind. So in the fourth energy level, the D's are which D's? 3D. 10. Okay. And then finally, P5. Sorry, didn't mean to distract you. Perfect. Okay. 18, 20, 30, 35. Please remember, you should be starting to see a pattern. What do all levels begin with? S's. Maybe S2, but S's, right? And again, when I come over and I ask you and I say, what is this area? A lot of you are going, that's the S's. But you need to be a little more specific. Is it the 1S, the 2S, the 3S, the 4S? Okay? What does every row end with? P's. And the P's and the S's are the same level. So 4 and 4, they're in the same level. Okay? If, however, we get far enough down that we have to include D's, the D's are always 1 less than the S's. So if you're in 4 here, you're going to be in 3 here. If you're in 5 here, you're going to be in 4 here. Now if we throw in the F's, they're how many behind? 2. So until we get to the 6th energy level, here we don't have to worry about F's. But then when we do have F's in the 6th energy level, which F's are they? If they're 2 behind, what? They're the 4 F's. And these down here are the 5 F's. Now also in the 6th energy level, you're going to have F's and you're going to have D's. Okay? So you have F's and you have D's. The D's are still only 1 behind. In the 6th energy level, it is 5 D's. In the 6th energy level, it is 4 F's. F's are always 2 behind. D's are always 1 behind. Okay? Good. All right. How about osmium here? All right. Osmium. Go ahead, Jaden.
5E1, 4F14, 5D6.
54, 56, 57, 71, 77. 1 too many. Now, you did everything right. First of all, Jaden, you followed it exactly on the periodic table. But in this 5D6, we have accounted for this 5D1. So you do not need to list them separately. Okay? You will only ever list an area once. You won't split it up. You won't be like 4F2 and 4F3. No, never. Okay? So we do not need to write this on here because it's already part of this. Now, there is a time when we're going to have to do that, when we're going to have to do a D1. And we're going to show you that right now. Okay? Stephen, what is our noble gas core for uranium? Which one do we use?
Radon.
Radon. Radon is 84, correct?
Yeah, 86.
I'm sorry, 86, my bad. So then where do we go from there?
7s2, 61, 5f2.
5F what? I'm sorry. All right, so 86, 88, 89, 92. Now, Jaden, and for everybody, here is where you need to include that one. You have to include the 6D1 here. And the reason you have to include it is because you're stopping somewhere in the X. And if you don't, you will come up 1 electron short. So if we go F1, F2, F3, F4, F5, F6, whatever, when we do it and we end it, F3, if we don't put that 6D1 in there, you're going to come up 1 electron short. And that is because, again, chemistry is full of weird exceptions, ladies and gentlemen. I'm sorry. It is. And the exception is this one right here is a 6D1. And it technically fills before these do. Now, the one above, we didn't include the D1 here because we made it all the way past the F's and back into the 5Ds. So these 5Ds, this one here, the 6th one here, has included this one being in this spot already. So we don't need to write it separately. Okay? We don't need to write it separately. Questions? There are 4 of these on your test or on your quiz tomorrow. Now, here's the bad news. I put the quiz back on Google. Okay? In Google, you are not going to be able to make superscripts. You're not going to be able to do that. Okay? So here is my question to you. Are you guys okay typing this out, 4S2, with the 2 being bigger, or do you want me to put those questions on a sheet of paper so you can write them out?
Paper.
You want it on paper?
Yeah.
I will make that adjustment for you then. I will make that adjustment for you so that you can write them the way you want. Now, you also will have a choice. If you're still a little confused on these noble gas cores and you do not want to use them, you do not have to. But then you got to get it right. You got to get what it's taking the place of. So here you would have to write 1S2, 2S2, 2P6, 3S2, 3P6. You want to do that and you can get that correct, I'm fine with it. If you want to use this so you don't have to write all that, absolutely fine as well. Questions? Okay, so you may be wondering, well, if that's 4 of the questions, Mr. Brand, what are the other questions on? The other questions are on quantum numbers, ladies and gentlemen, and electromagnetic radiation. So, for example, how many p orbitals are there? How many d orbitals are there? How many sublevels are there in the 2nd energy level, in the 3rd energy level? How many electrons fit in any orbital? Which has a higher wavelength? Red, orange, yellow, green, or blue? Okay? Those are the types of questions that you will get. Now, I handed you a periodic table today. I will hand you another one tomorrow. I told you a key to this test is to be organized. Okay? Now, if I were you, on the bottom of this paper, I would probably put the electromagnetic spectrum. I would put radio and TV, micro, infrared, Roy G. Biv, UV, X-rays, gamma. And then underneath it, I would put wavelength. Increases or decreases. Energy increases. Frequency increases. Just like we did at the start, but I'm sorry, I have not corrected this yet. In your notes, get out of there. This actually belongs over 1.
Visible.
Yes. This should be under visible light, not under IR. My bad.
Can we use it on the quiz?
You want to use that on the quiz?
No, I was just, I don't think we can.
No, you can.
Yeah, no.
You want to use this on your quiz tomorrow, put whatever notes you want on it. You can, but that won't be any help at all. Because I'm not, if you have notes, sure, go ahead. Okay? This is the one that I'm giving you tomorrow, ladies and gentlemen. This is the front. This is the back. The difference between that one and this one is we're going to list on here trends that happen within a family that go up and down. On the back, we're going to list trends that go across. And then we're going to organize them for you. So, you want to use your periodic tables that I just gave you, these white ones. You want to use that yellow sheet that you got notes on. You want to use your periodic tables that you have notes on. You want to put something down on a sheet of paper. Bring it with you tomorrow. Okay? Bring it with you tomorrow. You can use it all on the quiz. Okay?
Why? Like, why?
Why?
Yeah, like,
Because there's a lot of information here. And I don't expect you to memorize it all. But I do expect you to be able to find it and be able to use it. So again, if you want to put a note on the back of that yellow paper with all the elements on it, that there is 1 suborbital in level 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5, 6 and 6, 7 and 7. Go ahead. If you want to write down that the suborbitals are S, P, D, and F, go for it. If you want to write down that there's 1 orientation of an S, 3 of a P, 5 of a D, 7 of an F, go for it. I'm fine with it. Okay? I'm fine with it. I don't expect you to memorize all this stuff. I do hope that you can understand how to get it from maybe the periodic table or your notes that you have. So go ahead, make them however you want them. I don't expect you to remember the electromagnetic spectrum. Jesus. Took me 20-some years to get to know it. Okay, so write it down for yourself. Put it on the bottom of your sheet. Okay? Put it on the bottom of your sheet. You already wrote on the front of that yellow sheet that hertz is the unit for frequency, right? So I'm just checking. Maybe that might be helpful information that's on the front of that yellow sheet then too. You should probably use that tomorrow as well.
You only use one of the sheets.
Which one of the sheets? What do you
Like
mean?
if I wanted to use like this and this.
Go for it.
Okay.
You want to use that and write stuff on a separate sheet of paper? Go for it. But you got to write it on a separate sheet of paper.
Yeah, I've never had this in freedom.
Well, this is the way your test is going to be, so I might as well get you ready for it. Do you think I'm going to make you memorize all this crap and then go into a test and do it on your own? You think I'm that much of a jackass?
No, that's not it.
That's what you meant.
No, I'm just saying.
Okay, questions? All right, then I need you to get to this slide in your notes, ladies and gentlemen. Boom. This one. Slide number 16, ladies and gentlemen. There are different ways of looking at things. We have been looking at breaking down and identifying every electron in every energy level, describing all of them around the atom. There's another way of looking at this. Who cares if they're in an S or a P? Maybe you just want to know how many are in an energy level. So years ago, they decided to give the energy levels letters to represent them as well, just like they did for the sublevels, the S, the P, the D, the F. Well, they gave the principal quantum numbers a letter as well. For 1, it's K. For 2, it's L. For 3, it's M. For 4, it's N. For 5, it's O. For 6, it's P. And for 7, it's Q. So, I'm putting it to you, ladies and gentlemen. I'm on this slide. You can get there if you would like. Give me an element that you want to write the configuration for. Pick one. Okay, hold on. Slow down. I got oxygen and I got rubidium. Let's do them both. Okay, let's do them both. What's the first one that came to your mind? Yeah, I can't do yeah, sorry. Oxygen, symbol O. The electron configuration, 1s2, 2s2, 2p4. Correct?
Yep.
You buying that?
I buy that.
Okay, good. How many electrons are in the K energy level? Why do I feel like I just spoke ancient Greek to you or something? Well, what does the K represent? Okay, which is which energy level? Which energy level is the 1 principal quantum number? Oh my God, do you got a lot of writing to do on your sheets?
Yeah.
The first principal quantum number represents the what? Oh!
Wait, this is like the address analogy, right? The energy level.
Thank you! So what energy level is the first? The first! So how many electrons are in the first energy level of oxygen? 2. Guess what? This can never be larger than what number? 2. Why? You can't fit more than 2 in the first. That's it. Okay, how many are in the second level? No!
10.
No!
4.
No! God, can you not count?
No.
Thank you, Phoebe. 1s2, 2 in the first level. 2s2 and 2p4. 2 and 4 is 6. Now, how many, stop, listen, how many maximum in the second level?
10.
8.
I remember this from.
Okay, how many maximum in the third level?
12.
Quit just guessing god dang numbers and think about the model that we just said. What are the sublevels in the third energy level? What? That's it?
In the third?
In the third.
S1.
S, P, and D. How many fit in the S? How many fit in the P? How many fit in the D? What's 2 and 6 and 10? 18. Now, granted, the 3 Ds do not fill until the fourth energy level, but they are still part of the third energy level. Almost afraid to ask this question, but I'm going to. How many in the fourth?
32.
How'd you get 32, King?
Because I looked at this.
Dang it, I was hoping you were going to tell me how we could figure it out.
No, I have no idea.
Yes, you do, because I just gave you how to figure out the S's. What sublevels are in the third energy level are what sublevels?
SPD.
SPD. What sublevels are in the fourth?
SPDS.
Okay, how many in an S?
6.
How many? How many in a P?
Six.
How many in a D? How many in an F? 14. 2 plus 6 plus 10 plus 14 equals 32.
Add the numbers on the side.
Oh.
That's like the level.
How many in the fifth?
Wait, like this?
How many in the sixth?
32.
How many in the seventh? Now, can you have less than the max? We just did. In the L level, we only had 6. Okay. So what was our other one that you wanted to do? Somebody called out rubidium? Rubidium, right? All right. Give me the electron configuration for rubidium. I sure would rather it with the bracket, but if you want to do it without, you're welcome to.
KR with the bracket. Which would be 5S1.
Whoa, 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 whoa. You forgot something.
Oh, thanks.
Where's that?
KR what?
KR4.
That's one.
What do we got to put by the KR, ladies and gentlemen?
The
What?
Oh,
What?
36.
36.
4S1.
Then what?
4S1.
Try again.
What?
5S1.
Oh yeah, sorry.
How do you do a bracket?
What do you mean, how do you do a bracket?
Yeah, how do you do? Why doesn't it go the other way?
It's next to the P on your keyboard. Okay, now, you wanted to do this, Joshua. Now the problem is, how many in the K, how many in the L, how many in the M, how many in the N?
Wait.
2, 8.
Boy, it is a shame that you people are blind.
34. 33. Sorry. 33.
In what level?
Oh, sorry. In total. 2 and then
2.
2 and 3.
2 in the K,
8 in the L.
18.
18 in the M. 32 in the N. And 1 in the O.
really?
Yeah.
Add these numbers up.
32, 33.
Does not equal 36.
That does not equal 37 the last time I checked.
It's too big.
Wait. Oh, no. 28.
Oh, it's 8, then 18. Or M, it's 8, and then N is 18.
It's 7 in the end.
7 in the end. No. You know, I wish somebody were nice enough to give you the numbers that would belong there based on the noble gas on your periodic table. Oh, it's like he understood what I said. I don't know if he actually did or not.
So K is 2,
2,
L
8,
is
18, 8.
M is 8.
Nope, wrong.
2, 8, 18, 9.
What?
2, 8, 18, and 9.
2, 8, 18, and 9. 2, 8, 18, and 9. 2, 8, 18, and 9. Now, the last time I checked, ladies and gentlemen, how many valence electrons can an atom have maximum? 8. So to me, just thinking about that, this is the outermost level, and we just put 9 in there. That doesn't seem right to me. Not to mention, 2 and 8 is 10. 18 is 28. 37, we're good there. But that ain't right, is it? That can't be 9.
Why?
Because you can't have more than 8 ever in the outermost energy level.
It says 34 there.
Boy, I really wish you would look at your periodic table for some help. What are the numbers right next to krypton on your periodic table?
2, 8, 16. Oh, wait.
2, 8, 16. Where the frick are you getting 16
It
from?
looks like a 6 on mine. It's like scratched out.
does.
What are they?
2, 8, 8.
18, 8, 8.
Stop. That's it. That's all that it says there, right? So,
That's what I said.
didn't
Uh,
when?
Before.
You didn't say it in English.
No, I did.
2, 8, 18, 8. How many is this?
36.
Huh, same as this number right here, huh? So that must mean that these accounted for all of these, right?
Mm-hmm.
So where does this one go?
And the O.
In the O.
Wait, check the risk mark.
Dude,
So you can use a noble gas core, absolutely.
it's easier.
And when you do, the numbers are written on the side for you
Oh.
that go into the K, the L, the M, the N, the O. But it doesn't account for what? It doesn't account for what you write after it. Okay? Doesn't account for what you write after it. You know what? You know what one of my favorite elements is, ladies and gentlemen?
Branium.
There it is. Uranium and oxygen. You people think way too much of me. Gold! Gold, ladies and gentlemen. Gold!
Can we do CF?
Like jewelry.
Can we do CF? Oh.
AU, gold.
Want to chain real cool?
I hope so. Either that or my mom's been lying to me for years.
What's your favorite one?
So, ladies and gentlemen, let's write the configuration for gold. Do you want to use the shortcut?
Yes.
I would. Okay, what's the shortcut start with?
Where's gold?
Xenon.
Good, I've gotten 2 answers to the same question. Could someone help me out here with one answer?
XC.
X. X.
Xenon, 54.
Yes.
Oh, wait, yeah, Xenon. I'm sorry. My bad.
Okay,
That was me.
now let's finish it. In that 6th level, what do we got? 2. Don't you dare start with the KLMNOPQ yet. We have not yet finished writing the configuration. Finish the configuration. 6S2. Then what?
4F14.
4F14. Then what?
5D9.
5D9.
5D9. Okay, 79 total electrons, correct? 54, 56, 79, correct? Good. For xenon, what do I write? 2, 8, 18, 18, 8. Now, stop. Now we need to add in everything that we wrote after that. 6S2. Where do those go? They go in the P. How many? Don't everybody shout it out all at once.
2.
2. 4F14. Where do they go?
P. No.
No.
Q.
No.
What?
They're not in the 7th energy level. They go in the N. So take that 18 and make it what?
32.
32. Oops.
Oh.
You said, oh, Nikki.
Where do the 5D9s go?
In the O.
Which makes the O what?
13.
17.
Give me the strength.
Oh,
Yeah, 8 and 9 normally isn't 13.
it says 5.
What says 5?
5D5.
Right, 5D, 5. 5th energy level, better known as the O.
Looks like a 5.
So this is 17. This is going to be tough for you guys because I'm going to require you to add things. 10 and 18 is 28, and 32, 60, 77. Oh my God, 79, we got it right.
Can we do CF?
Can we do what?
CF.
Where the?
98.
Okay, let's do CF.
I'm so confused.
Okay, stop. Why?
I don't know where we're getting these numbers from.
Me too.
Okay, please listen. Listen. Then listen. Don't talk to him. He's as confused as you are. Listen to me. For xenon, we put 2, 8, 18, 18, and 8. That's what we put for xenon, right? Look next to xenon on the periodic table. Do you see the numbers 2, 8, 18, 18, and 8? Okay. So for xenon, there are 2 in the first, 8 in the second, 18 in the third, 18 in the fourth, and 8 in the fifth. But when we go to this configuration, now we have to add 2 more to the sixth. That's the O, that's the P.
Oh.
I have to add 14 more to the fourth. So yes, xenon had 18 in the fourth, but now gold has another 14 more. 18 and 14 is 32. So I up this number. I also need to up the number in the fifth energy level by 9. Because in addition to the ones that were here in the fifth level, now I have some more in there. So my 8 becomes a 17. Okay? Now let's work through CF. And again, it'll be one where we're going to have to go back and add some. So let's do this one. Okay? So now, what noble gas core do we use for it? Neon? We're going to have a lot more to write if we use neon. Nope, we can't use OG because OG is in the same period.
Oh, man, CF.
What number?
86.
86. Okay. So what goes next? What goes next? From radon, what goes next? 7S2. Everybody sees radon at the end of the sixth period, correct? Yeah. CF, for those of you who haven't found it, it's number 98 on the very bottom of our periodic table. 98 on the very bottom. So now we're in the seventh energy level, and we did the 7S2. What's next? 6D1. And the reason we need to list 6D1 first is because we're ending in what?
F.
Which Fs?
5F.
5F.
5F. 9.
9. Okay, so let's do radon first. The numbers next to radon, the ones we had you add yesterday. Some of you had them, some of you did not. What were they? 2, 8, 18, 32, 18, 8. Now we need to add how many in the Q? In the seventh energy level, how many do we need to add to that? 2. Where does this 6D1 go? Into the P. So instead of an 8, it becomes a 9. Where does the 5F9 go? In the O. So instead of 18, it becomes 27. 2 and 8, 10, 28, 60, 88, 87, sorry, 96, 98. You have accounted for every single electron. Questions? Okay, I'm going to give you some numbers. You tell me what element it is. You ready?
6 9.
You like that Cheeto?
2, 8, 18, 6.
8, 18, 6.
Yep.
SE.
Yeah.
How'd you get there?
I took krypton and -2 from the 8 at the end of it.
Okay.
Yeah,
Why Krypton?
because that was the noble gas that had the same 8 and 18, and then it had 8, but then I subtracted.
Okay. You want to know the way I would solve it?
You add it.
Add them up. Add them up. Oh, what's the number?
34.
That's got to be the number of protons because
I see.
the atom is what?
That's making stuff complicated for us.
No, hey, if it works for you, that's fine. But it's going to get real complicated when you get into something where it says 32, 27, 9, 2. Because it's harder to see the noble gas core in there. Okay? But if you add these up, there's only one element on the periodic table that when it's neutral would have those. Questions? Any? Okay. So in your packet, ladies and gentlemen, there is some practice for you with this. Now, please understand, number one, this is not on your quiz tomorrow. As far as on the quiz is electron configuration. Okay? But this, ladies and gentlemen, would be worksheet number 3. No, is it 3? Yes. Worksheet number 3 on your periodic table. Now, the nice part about worksheet number 3 is it makes you do everything you were doing on worksheet number 2, which is right out of configuration, but then it extends it a little bit more. So, I would recommend very highly, you don't have to do all the problems on worksheet number 2. But if I were you, I would be able to answer all the questions on the bottom here. And if you can't, hey, Mr. Brand, can you come give me a hand on this? Because those are the type of questions that you may see on the test.
Which?
Okay, those two. Okay?
Where's the winter test?
Your test is on the final exam date, which for you guys
28th?
will be the 28th, 9:15
No.
till...
29th, right?
No, what hour is this? Second hour, you're right, sorry, this is second. Yours will be on the 29th at 7:30 a.m. You'll get to start your day with me. How much better does it get? What? We did that special just for you guys. You are my leap class. You're the leap class, okay? You're the leap class. You guys are my favorite second period class this trimester. You are.
Wait, are those arrows gonna be on it?
No. No. The arrows were just to help you understand how we're filling in what. Okay? That's all the arrows were for. Now that we've gotten beyond them, you don't need them. But there may be a question on a quiz sometime or on a test that says, okay, when electrons are filling p orbitals, how do they fill p orbitals? And the answer would be singly first, then doubly. So you understand what I mean by that?
So
They go into the px, the py, the pz, then they start doubling up. Okay? So there's 3 orientations of them. So I probably wouldn't ask you something like that, but I may say that
16.
the D orientations are all half filled. So how many D orientations are
Or is
there?
it 2, 8? Oh, it's
How many?
2, 8.
Okay, how many D electrons are there? 10. So remember, so there's 5 orientations, right? So if they're all half filled, how many would there be? 5 electrons. 5 electrons.
Wait, okay, then I have a question.
Okay.
It says how many electrons is bromine. Then how do you find that?
You go on the periodic table and you look at the number for bromine, and you take the number of protons, and that's also the number of electrons in neutral bromine.
But then this is.
2.
Yeah, it's not neutral. When they're charged. When they're charged, your protons and your electrons are always the same. Oh, don't worry.
Oh!
We're getting there.
And then.
I know that excites you, but we gotta get
I don't know if this is right.
¿Y si vamos a jugar fútbol?
Mr. Brand, can you help me real quick?
I don't know. I'm not a psychiatrist.
I've done it.
No, chemistry was. Okay. I don't.
Okay, so start by writing what you've got right next to argon.
Okay, so
Go ahead and write what you got next to argon.
2, 8,
this one?
8.
Okay, so now,
You would add 2.
in the fourth energy level, there are how many more electrons?
Where is it?
So find the fourth energy level and put a 2.
Wait, fourth energy level.
They're in order from 1 to 7.
Oh, so the 2 right here, right?
Okay. Now, back in the third, there are how many more?
6.
Same with
Go to the third and add 6.
whatever it is.
So this would be 14, right?
Yeah.
Oh, okay. I don't know. It just didn't
Now,
make sense.
one of the things you have to be careful of though is it is possible in a configuration that you might have 2 S's and 2 P's. Don't forget you would have to add those together because they're still all the second period. Okay?
That makes sense.
Good.
Yeah, it just didn't make sense. When
I
you were-
understand. That's absolutely fine. That's why you doing it is better than me telling
Yeah,
you.
thank you. Appreciate it.
Question?
Yeah, what are,
Or what?
what
I
are,
would do. I would do. Yeah, I was supposed to do that.
Okay, that's how we got to our configurations. Okay? That's how we got to our configuration.
HE,
So, here's what I will tell you.
HE,
The first quantum number represents the energy level, 1 through 7, right?
2.
The second quantum number represents a what? Subsidiary, which is a sublevel, right? Now, what are the sublevels?
1, 2, 3, 4. S, S, P, D.
S, P, D, and F. What number represents an S? 0. What number represents a P? What number represents a D? What number represents a F? Great, good. Okay,
Is that how you
so
do
now
it?
on the test,
Okay.
the question is, the element named after a high point of a wave is in the same period as the number that represents a d orbital. What number represents a d orbital? 2. So it's somewhere in the second period. Now I'd have to give you more of the clue and maybe say it's a noble gas. It has a +3 charge, has a -3 charge, but you know it's somewhere in period 2. That's where, okay, those quantum numbers come in. You have to know that an S represents the number 0, a P represents the number 1, a D represents the number 2. Or it may be this element, named after a high point of a wave, is in the same period as a number that represents the d orbitals and has as many valency electrons as there are d orientations. So the number that represents the d orbital is what? How many orientations? Always half of the total number of electrons.
What's an orientation?
An orientation means that, can I draw this? How it's arranged in space. So the reason that an S has only one orientation, okay, is because here is its shape. So no matter how I turn this, it always appears to look exactly the one. So therefore, there can only be one orientation. Here, you can have this back. For a P, I'll actually pull them out for you, show them to you. This is what our P's look like. So here's an S, sphere, right? Here are our 3 P's. And this is how they are orientated in space. Along the x-axis, along the y-axis, and along the z-axis. Okay? So there are 3 orientations of them in space. So you put that all together, and this is what it looks like. Here's the S in the center. Here are the 3 P's around it. 2 electrons in here, 2 between here and here, 2 between here and here, 2 between here and here. So that's the 3 orientations. For D's, there are 5 orientations. Why? Because here's the shape of a D. It's kind of offset this way. This one's kind of offset the other way. This one's offset here. And this one's offset here. Okay? And these are outside of this, so it can't be in
Don't tell me.
this direction because there's already these P's there. So it's got to try to fit in between. And that's what they're showing you here. And here's the weird one. Okay, I don't know how to get into that one. But the point is there are 5 different orientations here. Quantum numbers say that because n equals 1, the L equals 0. Negative 1, negative L, negative n, 0 to n minus 1. So mathematically, we can figure out how many different orientations there are. Then, after we do the sublevels, the M, the orientation is based off of the sublevel. If your sublevel is 0, the values of the M are from negative L to L. L represents the number that is the subsidiary number. So when L equals 0, M equals 0. That's the numbers from 0 to 0. But when L equals 1, now we get 3 values, negative 1, 0, and 1. Okay? So the model is there to try to explain how we can get so many different orientations, how we can get so many different areas, and things like that. And it's all based on the energy level. An energy level can only have so much room. Okay? So once you know the energy level, you can figure out the sublevels. Once you know the sublevels, you can figure out the orientations. That's what it amounts to. Now, we kind of explained that to you. You don't have to understand how they did it, because now we've shown you, okay, there's only 3 of these. There's only ever 5 of these. There's only ever 1 of those. That's just the way it is. But I could go back and I could refer to a quantum number as, okay, the number for a p suborbital is a 1. The number for a d suborbital is a 2. The number for an f is a 3. Well, I expect you to know that. I expect you to know that the d is represented by the number 2, the f is represented by the number 3. So if I ask you a question where I say, all right, this element is in the same period as the number representing a d orbital,
So it's in
the
2.
d orbital, it's got to be in period 2.
So would that be like the level?
Correct. Correct. So when you're putting your clue in now, okay, we said the high point of a wave, the crest. It's going to be somewhere in period 2.
So we're only
Now I'm going to have to give you another part of the clue that tells you where within period 2 it is. So, okay, it has the same number of valence electrons as there are d orientations. There's 5 d orientations, right? So 1, 2, 3, 4, 5 valence electrons. Second period, you would put crestage right where nitrogen goes. And I'm going to review some of these things on the periodic table with you still. We're going to get to those next week. Okay? That's also why I'm giving you this. So that, okay, on here, you could put down 1 valence electron, 2, 3, 4, 5, 6, 7, 8 valence electron. Then you can put down charge, +1, +2, +3, +4, plus or minus 4. So that everything that is a trend of a column, a trend of a family, a trend of a group, will be in one spot for you. And then here we'll put trends that go across the periodic table to help organize you. Okay?
More clear than that. So it's only ever gonna get to like 4. We're not gonna go past that.
No, we're going. We're going.
I was like,
The test looks like this. There are 50 blanks on here. That's what your test is. It doesn't include these.
28,
It doesn't include these, Eric.
28 plus
It doesn't include these. It doesn't include these on the bottom.
41.
It includes group 1, 2, and 13.
Just stop. Let me stop. This is about
Okay? So we've taken this, we've squeezed this together
no.
so that this is next to this, and that's what this represents.
That's not
Right?
1, 2. I just want to rock.
So look at the periodic table. Here's 3p, right? What's next? Or what? Or D.
That's a lot.
Here's 3p. They're full. What's the next thing?
D4.
There's your answer.
So 52 plus 2.
Okay, start after the 3p's.
60.
This 1 through 7 is
Yeah,
how many
right.
So I just didn't end up with
What's after the three S or
Don't
four
they
S?
do the F's?
and
What's after the four S?
Don't-
No. Greedy. Well, these are the four S. What's right after? How many are those are there? How many D's are there? 10. No, they're not 10. The other case, it holds 20 electrons.
So these are measured
Orbitals are always half the total number of electrons.
oh, just 4
Why? There's 10 electrons.
1 through 7.
There are 5 orbitals.
What?
I think the procedure should change that.
Yes.
See, that bit is like-
I could see him singing that.
Okay.
The zebra.
Orbitals are always half the
There's
Yeah, maybe not that much. There are 10 Ds. The orbitals are half the Most orbitals are half.
No, I don't. You just said there's 4. No, every time I send you our flashbacks, you never respond to them. Maybe the Snapchat flashback I send you, you never respond. I literally sent you one, like not that long ago, you lucky I don't.
I cannot stress enough to you, ladies and gentlemen, that your periodic table will help you tremendously when a question asks, what happens after this? Because it's right there on your periodic table for you, and I think we've got it all written down. Have a good day, ladies and gentlemen. Get out. Goodbye, goodbye, goodbye.